Hi, welcome back to LeetCode. So in this video, I am going to discuss the second problem from today's weekly contest 488, that is merge adjacent equal elements. So the prerequisite for problems for this actually problem is that try to solve this problem first, valid parenthesis. LeetCode question number actually is 20. You can actually first solve that problem, then actually it will be relate how actually you can solve this problem. Then actually come to this video again if you're still not able to solve that problem actually. So the uh, problem student is that you are given an integer array names. You must repeatedly apply the following merge operation until no more changes can be made. If any two adjacent elements are equal, choose the leftmost such adjacent pairs in the current array and then replace them with a single element equal to their sum. Both actually same. That means what will be the new number? That will be 2 into current number, correct? So after each merge operation, the array size decreased by 1 because we are removing two elements and we are adding new number, so that's why ultimately size is decreasing by 1. Got it? Repeat the process on the updated array until no more changes can be made. Return the final array after all possible merge operation. So let's take example 1, 3 1 1 2. So that is 3 1 1 2, 3 1 1 2. So they mentioned that we have to remove the first pair, that is present leftmost pair, that actually adjacent number actually same. Okay, so I iterate from left to right. So this 3, this is 1, not same. Come to this pair, yes, 1 and 1. So this will be actually replaced. First it will be removed, then it will be replaced by which number? That is 2 into the current number. That means our array will be 3 2 2. Clear? Because here you can see that we have removed two elements, 1 and 1, and which number we have that new number, that is 1 plus 1, that is 2. That's why you can see that the updated array is now 3 2 2. Okay, next again check this 3 and 2. Again we have to check left to right again. 3 and 2 both are not equal. Okay, let's compare this next two numbers, 2 and 2. Okay, again both are actually equal, so we have to remove these two elements, this 2 and 2, and we have to add a new number, that actually 2 plus 2, that is 4. So our updated array will look like 3 comma 4. Correct? Again we will check from left to right. Okay, left to right, this is the one number, this adjacent number is same, 3 and 4, no. So we'll stop here because there is no change in now, there is no change in the current array, so we can stop here. So our array, our answer array will look like 3 comma 4. This is clear. Here you can see that our output is 3 comma 4. Clear? Next again take this number, example 2, 2 2 4, 2 2 4. Okay, so I'll iterate from left to right. These two and these two both are equal. This is the first leftmost pair, that is adjacent pair, that actually same. So I'll first remove this and I replace with which number? New number will be 2 plus 2, that is 4. So our new array look like 4 comma 4. Clear? Again I will start from left to right. Is there any change? Yes. Here actually you can say this is, I found one adjacent pair that actually both are actually equal, 4 and 4. So it will be first removed and I have to what I have to do? I will replace a new number, that is actually 4 plus 4, that will be 8. And there is only one number, so I'll stop here. So this will be our answer. Actually you can see that for example 2, our answer is output is 8. Clear? Next is this 3 7 5. 3 7 5. So I'll start iterate from left to right. First I'll check this 3 and 7, these are equal, no. I'll go to the next pair, that is 7 and 5, both are equal, no. So I'll stop here because I have checked all the adjacent pairs and I have not found any change, like any pair that actually equal. So that's why I'll stop here. So that will be our actually output, our answer. Got it? So how actually solving this problem? Just try to observe the steps we are following. So first of all, you can see that we are first checking left to right, and however we actually found any match or any adjacent pair that actually equal. So I'll actually replace that and replace with which number? 4. That is the 2 into the current number. Got it? In this we will continue. So that means we actually have suppose 6 3, 3, suppose 2, 2. Okay. So first of all, I will go from left to right. Okay, left to right. So first of all, adjacent pair you have to check. First of all, I will store 6. You can actually think about how actually you can solve this by using stack. I'm giving enough hints to solve this problem by your own actually. So still you're not able to see, please continue this video now. So 6, first store 6, because there is only one element I have seen. So there is no adjacent pair is possible. So I'll come to next number 3. So when actually I can remove this. So if whatever the previous number I have seen, that should be actually equal. Is my previous number actually same? So how actually we have to check compare with this number, because our this array can be updated, and updated value will be stored into this stack. Okay, that's why I will, if actually I'm currently have ith index, I will not directly check with I minus 1 index. Clear? Because this can be changed, this can be removed, this can be replaced with a new number. Correct? So that's why I'll check with the stack that whatever the number is present at the top, that is the last element I have seen. Correct? So is this 6 and 3 actually equal? No. So I cannot remove, I cannot do any operation. So I'll directly store 3 here. Okay. Next, come to this next element 3. So I'll check that whatever the number present in the stack top of the stack, that is 3. So 3 equal to 3 current number. So I can actually apply this operation, right? So what I have to do? I have to first remove this 2 number. So that means I will remove this 3. 1, 3 already removed, and this 3 I will not store into the stack. Correct? So that means we have removed these 2 elements. Now I have to store back into the stack. What number I have to store back? That is the 3 into 3 plus 3, that is 6. So I'll store back 6. Okay. Now you can observe one thing, that after replacing 6, you can see that the next top actually is same. 6, both are actually 6. First I'll push 6. Again, the whatever the next number actually I have, previous number I assume that is 6. That means both will be actually popped, right? Both will be actually popped from this stack. And which number I have to add here? That I will add 6 plus 6, that is 12. Clear? So that means what? Just try to draw the actually updated array. So previous, initially I actually have 6, 3, 3, 2, 2. Okay. First of all, I have removed these 3. So our array will look like 6, 6, 2, 2. Okay. Again, I am iterating from left to right. So 6 and 6 both actually same. So I'll remove this and replace with 12. 2, 2. Okay. Next, again, these 2 actually same. So I'll remove this and it will be replaced by 4. And I will see that, okay, these 2 pair actually not same. So I'll stop here. I have checked all the adjacent pairs, right? So that's why this is our flow. So that's why when actually replaced with a new number 3, 3, that is replaced with 6, I have to check that previous number actually also same or not. If it is same, that also will be popped back. We have to continue, right? Until our stack top, whatever the number is present at the stack, that should be equal to the current sum or current new number. Correct? So I have to continue till that point, right? So that's why, got it. And ultimately, whenever we didn't, suppose here you can say that 12, there is no match after 12. So that's why I'll continue, go to the next number 2. So I'll store 2 here. Got it? Because the previous number actually I have seen, I actually have currently updated number actually I have, that is 12, not 3. Here you can see that, not 3, not 6. I actually have updated 12. So that's why I have to compare always with the stack top. Got it? And this is not equal to not equal to 12. So I'll continue, go to the next number, that is again 2. So here actually see that now actually we actually have whatever the value actually I have in the stack top, that is actually equal. 2 equals to 2. That means both of these 2 will be removed. Okay. So I'll remove this. Okay. And which new number I have to add here actually? That is 2 plus 2, that is 4. Got it? And now we have reached the end of this input array. That means whatever the number is present in this stack, that actually the final number that will be present in the answer array, or yes, answer array. So if actually now actually we have popped this from the stack, so it will be something like 4, 12. But ultimately here actually our answer is 12, 4. So that's why we have to reverse this, because this is stack. So this will be actually will get the value from reverse order. So that's why I'll have to reverse this, and this is our answer. This is clear? That means what are the condition I have to consider here? So we actually have one stack, right? So about stack. Okay. So if actually I'm iterating a new number, suppose, okay. So I have to check that if stack is empty, Okay, that means we cannot generate any adjacent pair, correct? Because this stack is empty. That means this is the first element I am looking into, right? So that's why I will directly store into the stack dot push a current number. Got it? This is the condition where the stack is empty. Else if it may actually have some element in the stack, there is two conditions. One is stack is empty, the stack is empty, or stack actually have some element, some number. So that means if else if means our array is our stack actually some element, then actually have two case. Case A will be when stack top equals to I, current number, and another case B, it will be when stack top, what is the number present at the top of the stack, that is not equal to. Then actually what will do? So these two I have to consider, right? That means if we actually have both are not equal, whatever the number actually I have previous adjacent element actually I have previously, that is not equal to the current element, that means we cannot do any operation. So I'll directly store into the stack push the current element I. This is clear. This is actually else if is not empty. All right, and there is two sub cases. All right, one is the case is that when actually our previous adjacent element is same, and another case is that when our previous element or adjacent element is not same. If it is not same, we will just continue, go to the next number and store the current element into the stack, correct? And when actually it is same, then I have to think how actually we can approach these steps. Actually you can see that when actually found any match, suppose for 3 and 3, stack actually have first actually have will store 6, then I'll store 3, then actually come to these 3. Currently I am at this added this 3, correct? I'll say okay, this top and this current element this is same. That means I have to remove this. So first of all, I have to remove from the stack dot pop. Clear? Pop these 3, correct? They mentioned that we have to remove both of this number from the final array, so that's why I'll remove from the stack. Now I have to store back what? The new number 3 plus 3 into the stack, that means 6. But we have to also consider that is this the new number, it is same as the previous adjacent number. It may possible here actually you can see that this 6 and the current new number after replacing this with 3 plus 3 both are actually equal, that we also consider. So that's why you have to continue until the stack top is again same. So that's why I will store this. Okay, this is actually same, so I will still sum equals to current number I plus I. This is the new number actually I'm going to replace, correct? And I will check that while our stack is not empty, and I'll check that if stack dot top equals to this current number, the current sum, then I have to pop also that number also. So that's why pop. I'll pop the top number, whatever number is present at the previous adjacent element, and else I will break from here, because I found any one adjacent element that is not same the current number or current new number I am going to replace. That time I'll stop from there. So I'll break from this while loop. Else I'll continue. Means if it both are actually equal, I have to pop this number from the stack, correct? And if it is equal, then what will be the new number? New number I'm going to replace, that will be 2 into sum. Clear? That means just observe this example. I actually have 12, now I actually have 6 and 6. Got it? So I'll come to this case A, that our top element is equal to the current element. Yes, 6 and 6. So I am going to replace what? While our stack is not empty, I'll check the new sum. It will be first of all I have to compare this is still equal or not. So that's why I have to check that if this 6 and this 6, what is stack top equals to current I or current number, then actually I have to do, I will actually pop this from this stack, and new number will be new sum will be 2 into sum, else I will break from here. Clear? And ultimately, whatever the final sum I can actually have, that will be stored into the stack after this while loop, because it may possible actually have that in the stack actually we have 2, 3, and sum actually we got that is 7, suppose. So is it actually possible to compare? Suppose we actually got 3 plus 3, that actually ultimately 6. 6 equal to 7? No. So our while loop will break from here, and ultimately I have to store 6 into the stack. Clear? So that's why whatever the sum actually I have, that will be stored into the stack dot push the current sum. Either sum will be 3 plus 3, or it will be actually matched, then it will be actually it will be increased, right? This is clear. All the condition that actually I have to consider. And if you still not clear, you can actually see this video again and also try to actually generate all of these conditions. One condition is that our stack is empty. Then what I have to do? We cannot generate any adjacent pair, right? So that's why I directly store into the stack. Else if our stack actually have some element, that means we actually have some adjacent element previously in the left side. So that time there are two conditions possible. One is the adjacent element is same, and another is that not same. If it is not same, then we cannot do any operation. We'll just directly store into the stack. Clear? In this case B, just store into this stack. The first case, that is when actually our adjacent element, the left element is same in the current element, then we have to check what I have to continue until the new number I'm going to replace, that is still same, whatever the number present in the stack, till we have to continue that point. If it is not same, that till that point. So that's why I'll actually handle that case. Got it? And how we can handle that? Now it will go to the code again. So the stack we have to take, this is we are going to store a long type variable, okay, and I'm iterating from left to right, so that's why I'm iterating from this input array nums. And there are two cases. One is that our stack is empty, another is our stack is not empty. So if stack is empty, true, that means I'll directly store into the current number into the stack. Else if our stack is not empty but the adjacent element is not same, that time we cannot do any operation. I'll directly store in here you can see the top element that actually I have, that is not equal to current number I, I'll directly store into this stack. Else we have to handle that when the adjacent element is same, then actually I am going to the new number, that is 2 into I, means I plus I, that means actually 2 into I. What? This is the new number I am going to replace, or I am going to add into the stack. And first of all, pop this, the top is whatever top is present, because both are actually same, current number and the top element or the left element. So that's why first pop that element from the stack. Now we have to check that still actually whatever the new number I am going to add, that actually same the update, this is same of the updated array or updated element or not. So that's why I have to check what if our stack is not empty, that means we have still some element in the left side. So that will check that whatever if it is whatever number present at the top of the stack is the same equal to the current sum, that is sum is the current new number that I'm going to add into the stack. So if it is same, that means it will be also removed from the answer array. So that's why I'll remove from the stack.pop. And whatever the new number I'm going to replace, that will be 2 into sum. Why? Because current number actually is sum, that is I'm going to add, and already current number sum is already present in the stack top. That means sum plus sum, that's why 2 into sum. This is the new number I am going to add. So that's why the new sum, it is actually 2 into sum. Got it? Else break from here if it is not same. Clear? Why not actually found any element, adjacent element that is not same with the current number I am going to add, that means we cannot do the operation. So I'll stop here. So I'll break from here. Else I'll continue. Still actually have some element present in the left side. Got it? And ultimately whatever the final sum actually I can actually have, that will be stored into the stack. Got it? Either stack will be empty, or we actually have some element in the left side that actually same. So if it is same, then actually sum will be adjusted, right? So that will be stack dot push the final sum after this operation. If block is true. Got it? It can be true 0 times, 1 times, or it can be multiple times. All right, and I'll store it into the stack. Ultimately I have to return the final array. So that's why I have to return the vector of answer, long type, and I have to check that while actually we have the stack actually have some element, I'll actually pop this from the stack. and ultimately whatever the numbers are present in this stack, I will actually push back into the answer array and pop this. Okay, that means we have transferred all the elements from stack to our answer array. Now you can see that this is stack. That means we actually last in first term. That means we actually have the element that is in the right side, right? But we have to return in the left to right order, right? So that's why I'll just reverse the, before returning the answer, I have to reverse the answer array and ultimately return the answer. Got it? So what is the time step for this? This is actually big of n. Why? Because I'm first of all, this for loop will run whatever the how much number is present in the input array nums. That means n times. Okay. Here you can actually ask that there is a inside of a while there is a one loop while loop, right? So this can take time, but what is the worst case actually it can take? There can be, if I am currently ith index, we actually have all actually are same. That time it will be run maximum n times, right? Because we actually have n elements in the left side of that. That means we actually this value will run n time. This is constant, right? Big of n plus n kind of. Got it? And this value also run big of n if there is n elements present in the stack. Okay, in the worst case. And ultimately reverse that. This also take big of n and ultimately return this answer. So time study is clear, big of n. And I have shared this in the description. And if you not subscribed, please subscribe the channel. Bye bye. Thank you. And if you like the video explanation, please like the video. It just motivates me to make more such videos. Thank you.